In this video, we're going to look at alternate and corresponding angles in parallel lines. And transversal intersects or cuts across two or more parallel lines. It could cut across three. So my alternate angles, what we're going to look at here, these alternate angles, we look at corresponding to in this video. Alternate angles, we can say, are always on opposite sides of the transversals. So you can see that these two angles here are the same. So they're my alternate, opposite sides, and then on same sides of the transversal, this angle and this angle are going to be the same. These are on the same side, and these are what are called corresponding angles. So let's have a look at a couple of diagrams in relation to this. Now, alternate angles, we can see here, they're on opposite sides of the transversal in these diagrams. Now, we're going to be dealing with parallel lines, these ones here. We're not going to really have many questions that deal with non-parallel lines, with these transversal cutting through non-parallel lines. So you can see my alternate angles, just write in alternate angles, opposite sides of the transversal. You can see here, they create a Z when we've got parallel lines. There's my Z. There's my backward Z. I prefer to look at this as Z on the other side here. This one here, the black going down this way. There's my Z. So you can see opposite sides, my C and my D. And remember to look out for this Z shape. That will tell you where your alternate angles are. Remember, they're on the opposite sides. Now, angles have a special property. So let's have a look here at what these special properties are. So if we have two parallel lines, the alternate angles, as I said there, these are the ones we're going to be dealing with where the alternate angles are equal. 1 and 2 are equal here. A and B are equal here. Put my Z in. There's my Z. A and B are equal. This angle here, if this was C, we could say that A plus C is equal to 180. We could say that A is equal to B. Therefore, or this implies A is equal to B. So we're going to replace A with B. B plus C is equal to 180. So you can see here, inside here, these two angles inside, these two, C and B, are equal to 180. And if alternate angles are equal, the converse, which we've looked at, the converse, just the opposite of this, if we have two parallel lines, then the angles formed are equal. If we have equal angles, then the transversal cuts two parallel lines. So theorem 3, if a transversal makes equal alternate angles on two lines, then the lines are parallel, and the converse of this is true. So corresponding again, corresponding same side. I'll look at this A and B here. You can see here, A and B, same side. E and F, same side. This funny diagram here with the non-parallel lines, they do call them corresponding angles, but we are going to look at mainly parallel lines in these cases. So again, on the same side here, 1 and 2, on the same side, they're corresponding to each other. A and B are on the same side down here, they're corresponding to each other. So alternate, opposite sides. So these two here, A and my dot here will be my alternate. My two, this guy will be my alternate. And here we have a mention of theorem 5, no need for a proof. But two lines are parallel if, and only if, for any transversal, the corresponding angles are equal. And remember that corresponding are on the same side. So you may be asked to identify them. And one really important thing to remember within these questions, that interior angles between two parallel lines add up to 180. We'll do a little proof of that. So we have two parallel lines. We want to show that the interior angles here add up to 180, A and B. We can just say that that's C. And because these are alternate, because of the parallel lines, angle A is equal to angle C. And we can say that angle C plus angle B is equal to 180. And we always write in Y, so here's now alternate. Here we have our straight line. So what can we say? We want to say that angle A plus angle B is 180 from above here. So if C is equal to A, we replace this C with angle A plus angle B is equal to 180. And that will be the proof that when we have interior angles between two parallel lines, they add up to 180. It's a helpful property when we go into questions. The proof is not needed, but here it is.